today we are going to be studying alkane. So now I'm going to divide this video into two, but this video particularly will be for everything you need to know about alkanes. But the second video about these alkanes will be advanced, so there are some things that somebody actually trying to learn what alkane means for the first time can't understand until he has a background, a foundation, you get. So now let's go into the basics and everything, all the introductions and the major points you have to note about alkanes. All right, so now let's move on. Okay, now the alkanes can also be called what? Paraffins. Now that's the first thing you have to note about alkanes. It's also called the paraffins. All right, now what does paraffin means? It's a foreign language. Now paraffin means little affinity. So now from the word little affinity, you can now have a glimpse of an idea of what we're talking about alkane. But now let's move forward. First of all, there are points I want you to note about these alkanes. Now, first of all, the first point I want you to note about alkanes is very simple. Now, number one, they are saturated hydrocarbons. Alright? Alkanes are saturated hydrocarbons. Now, secondly, what do I want you to note about alkanes? Alkanes, I want you to know that they have what? Single bond. They have carbon to carbon single bond. Alright? This is what I mean. Carbon to carbon single bond. Now guys, we now know that a saturated hydrocarbon is also a single bond, and now every single bond can perform what we call sp cube hybridization. Now we now know that what alkanes are sp cube hybridized. Alright, now what else are we to note about these alkanes? Now alkanes has a general formula, and what is that general formula? It's very simple. CnH2n what? Plus 2. This is the general formula for alkanes. Now, finally, what are we to note again? The first member of the alkanes. Now, what is the first member of the alkanes? This is the most popular compound in organic chemistry, right? This is methane. Methane has the general formula of what? CH4. How was this gotten? Now, we say since is the first member, we denote when n is denoted with 1. This n now in this general formula is denoted with 1. What will happen? 1 multiplied by this n will give us 1 carbon. 1 multiplied by this n will give us what? 1 times 2. 1 times 2 is what? 2. 2 plus 2, 4. This is what we got out 4 hydrogen. So that is how to get the molecular formula of methane. Now, since we've gotten this guy, now let's draw a structure. It's a very simple structure. The structure goes like this. Since we say it has 1 carbon, and carbon must be tetrahedrally linked to each other. Now, it's very simple. We have to put 1 hydrogen here, another hydrogen here, and finally the 4th hydrogen, which is now tetrahedrally linked to each other. Now you can now see how to represent methane as a structure. This is how methane is drawn. But that is not all. Alkanes have other members in his family. It's not only this guy, the firstborn. He has other members. Now let's go with the other member. With this same formula, we can also get the other members of this family. Now let's do it fast. Alright, we see methane is what? CH4, right? Now we have the second to be ethane. What is the formula for ethane? Ethane is now n now will now be denoted by 2. If you multiply this n here by 2, it will give us what? 2 carbon. Now this n here, if it's 2 times 2 will be what? 4. 4 plus 2 will give us 6. We'll now have what we call H6. Alright? Now the next one will be what? Prop. Represents 3. Propane. Now from this formula, if n is 3 here, what will happen to it? We will now say N. This 3 times this will give us what? C3. Then H here. What is going on here? You look very closely. Now, 3 now, we times this one, we give us 6. 6 plus 2 will give us what? 8. Now, we've actually written out 3 of them. But we notice something. The number of the carbon represents the number of N. So now, we now know that butane will be what? C4. The rest has a difference of what? CH2. The rest has a difference of what? Look, let's write it here. They have a different, this is another point you have to note. CH2, which is called what? It's called the methylene group. It is called the methylene group. Now, from here you can now know what's next. We don't even need to calculate the formula, but to be sure you will still calculate it. For now, multiply this, it will give you what? H what? H10. Now, the difference in hydrogen is just 2. So we can now know what's next. After butane, we have what? Pentane. Pentane will be what? Pentane is very simple. You just write it like this. H12. We'll be adding 2 in the hydrogen. And we can also enzene. We go forward. Enzene. Hex is 6. So now we just put it like this. Good. Add 2. Alright? Now, heptane. We know the difference in hydrogen is 2, so we can keep on putting it like that. And system, alright? And so on and so forth till when we get to 10, which is dec. After 7, which is hept, we have 8 to be oct. We have 9 to be non. We have 10 to be dec. So the 10, alright? You follow this procedure and you get all of them. Okay, that is for that. Now, I want to show you now how we can actually represent alkanes apart from drawing their structures. In the nomenclature of alkanes, we can also represent alkanes in strokes of line. Alright, I'll show you basically how we can actually represent alkanes in strokes of line. The way we drew these guys, we can all draw their structure. As I showed you how to draw methane, we can also draw ethane the same way. Just put your 2 carbon and balance your hydrogen. It's as simple as that. So now let's move forward towards the representation of alkanes in strokes. Now, how can we be able to represent alkanes in strokes of line? And beside alkanes, alkyl groups can also be represented with these strokes of line. Now, if you've not watched our former videos, now what is alkyl? Alkyl is very simple. Alkyl has a formula of what? CnH2n plus 1. What does that mean? If we remove 1 hydrogen from every alkene, we'll get what? We'll get our alkyl group. Alright? So now, this is, you just note it. This is the formula for alkyl. If you remove 1 hydrogen from every alkene, you will get a corresponding alkyl. Alright? Now, what do we mean? We say methane is CH4. CH4. If we remove 1 hydrogen, what will we get? We will get CH3. This guy is called methane. This one will be called methyl. Alright? Now, for what do we have again? We have what? What is this? This is ethane. If we remove 1 hydrogen, we will get a corresponding alkyl group, which is what? Ethyl. We now have CH25. This is what we call ethyl. Now, let me write it. Ethyl. This one is ethane. This ethane. This is methane. Alright? Now, the next one is what? Propane. Propane is written like this. This is propane. Now, we will now have corresponding propyl, which is what? CH3. This will be called propyl, and so on and so forth. So now I just wanted you to get a glimpse of what we are trying to say before we move forward. Now, what we mean is that we can represent alkanes and alkyl groups with strokes of line. So now let's get straight into it. Alright guys, now representing alkanes in strokes of line goes like this. It's very simple. Now from the look of things, it looks like a mountain. But it's not a mountain, it's a representation of what? Alkanes. Now let's go. How do we know how to like see this? Does this look like a compound? No. But how do we know? Every sharp edge represents what? A carbon. So now let's point it like this. Every sharp edge. 1, 2, 3, 4, 5, 6, 7. What is this? It's called heptane. Funny, right? This is heptane. So now we can just represent it with, we can put carbon like this so that we know what we are doing. Okay? This is what we call it heptane. Now, can somebody remember the formula of heptane? It's very simple. As we said, since we have 7 carbon, from our general formula, what? CnH2n plus 2. Now, let's get the formula of heptane. It's very simple. Now, if we say N is now 7 in this general formula of all alkanes, we now say C7, that is atom number 7, carbon atom number of 7. Now we will now write the formula as this. We now write it as C7. Then the hydrogen, we now calculate the hydrogen. If 7 is N is 7 here, we will now say 7 times 2, 14. 14 plus 2 will give us what? 16. So it's as simple as that. This is the general formula of heptane here, as easy peasy. Alright? Now let's move over to more complex diagram represented by strokes. Okay guys, the next example. Let's draw something like this. Okay. Now, looking at this diagram, it looks terrifying. We are confused. What do we do? It's very simple. Now, when you see the diagram being confused and being confusing a little bit like this, it's a very simple thing you have to do. What do we do? It's very simple. We count the longest carbon chain. Now, from the look of things, as I said, every sharp edge is a carbon. So now let's put 1. No, let's count it. Abina, let's count it. So now let's go. 1, 2, 3, 4. It's a bend. So now let's put it 5. If we put 6 here, this guy is definitely not the longest. If we put 6 here, we'll now call this our substituent. No, we have to move forward. Let's ignore this guy first. 6, 7, and 8. Now, from the look of things, we can now see that this guy is our substituent. So if he's our substituent, what we'll call this whole compound, we'll call it octane. But it's not just octane because it has a substituent. If this guy is a substituent, remember our substituent is our alkyl group. And if this guy is represented just by a stroke like this, what will we call it? Remember, if here to here is alkane, if there is a hydrogen missing, and remember every substituent always misses one hydrogen. So if this guy, this from here to here is alkane, and this thing, and is missing one hydrogen, it will call it methyl instead of methane. Alright? So now this guy, we have identified it to be what? Methyl. But that's not all. From the look of things, we know the number of atoms, but we will still consider something. We will consider the position of this substituent before we name. Which means we can't name like this. Abina, wait. 1, 2, 3, 4, 5. It's long. 1, 2, 3, 4. This guy is shorter. So we have to count from this side before I name it. So we have to count like 1, 2, 3, 4. We'll name it as 4 methyl octane. It's as easy as this to name it. Very easy. I believe now you can represent any alkane in strokes and be able to also name them with ease and with action. So now let's move forward. Now we are here, preparation of alkanes. This is very, very easy. Take your time, pay good attention, and trust me, you will get it. Now, first of all, the first preparation of alkanes is hydrogenation of alkanes. I think I mentioned something like alkanes, but now let's go. Now you find out more about it. Now, hydrogenation of alkanes. Now, you might find this word hydrogenation very funny. You know what hydrogen is, but not hydrogenation. It's very simple. It means the addition of hydrogen molecule. I didn't say hydrogen, I said hydrogen molecule. What does hydrogen molecule mean? Hydrogen molecule means what? H2. Okay? These are hydrogen molecule. One hydrogen like this cannot be called, these are hydrogen atom. Can be called hydrogen atom. This guy is hydrogen molecule. You now know the difference. Now, let's go into this fast. Okay, now, what is the general formula of alkenes? Because they say the hydrogenation of alkenes. Now, the general formula of alkenes goes like this: CnH2n. You see now, you now know the difference between the one I gave you before and this one. There's no plus 2, but there's no plus 2 in alkenes, but there's plus 2 in alkenes that we're actually learning now. Now, let's go forward. They said hydrogenation. In this reaction, there will be addition of hydrogen molecule. Now, let's write it. If hydrogen molecule reacts with alkenes, what will happen? It will give us what? It will give us alkenes. Now, the formula for alkenes says CnH2n plus 2. Alright? Now, there are conditions for this reaction. We have to use a catalyst. Which catalyst do we use? We have 3 catalysts we use. We use nickel, platinum, and palladium. Now, I said nickel, platinum, and finally palladium. Okay? These are the 3 catalysts we use. We don't use them at the same time, like we don't put the 3 together. No, we use one at a time. It's optional. The one you want to use is either nickel, platinum, or palladium. Okay, to get your alkanes. Now, guys, let's use ethane. Ethane as an example. If we hydrogenate ethane, what will we get? Now, if remember, ethane is the first member of the alkane family. I didn't say alkene, no. Alkene. Ethane is the first member of the alkene family. So now let's use it. Where n is equals to 2. Now 2 times this n will give us C2H. That is 2 times 2, 4. We get this. We call this what? Ethane. I think in our next class on when I'm going to be teaching about ethenes, alkenes, you will learn more about what we call alkenes. But now we're focusing on alkenes, alright? Now let's move on. If this is ethane, if we hydrogenate ethane, what will it give us? Remember, the hydrogenation is the addition of hydrogen molecule, not atom, hydrogen molecule. Now, which one will we use? Which one will pick? Let's just pick platinum. You can use nickel, you can use platinum, you can use palladium. Let's move forward. Now, what will it give to us? Adding this guy, it will now give us what? C2H6. Now, what have we got in here? We are gotten what? Ethane. Now, getting ethane, what does that tell you? Any alkene you use in the preparation, any alkene you use in the preparation of alkene, it will give a corresponding what? Alkene. If you use ethane, it will give you ethane. If you use propane, it will give you propane. If you use butane, it will give you butane. Are we good? Now let's move over to the next preparation of alkene. Now guys, now we move on to the next preparation of alkanes. Now the next preparation of alkanes is called decarboxylation. Alright? Now let's write. Alright guys, decarboxylation. What do we mean by decarboxylation? It is the reaction between what and what? Between salts of alkanoic acid. The reaction between salt of alkanoic acid and what? Caustic alkaline. Now, what do we mean by caustic alkaline? It's a very popular something, sodium hydroxide. This is what we mean by caustic alkaline. We also have potassium hydroxide. We can also use other caustic alkaline, but let's use this as a case study. Okay, salt of alkanoic acid. We have different sorts of alkaline. We have sodium ethanoate. We have potassium ethanoate. All right, but now we are going to use sodium ethanoate and sodium hydroxide as a case study. But now there's something I want you to know. Caustic alkaline is very reactive and deliquescent. This guy here is very reactive and very deliquescent. So now what do we do? Because it's not good using a very reactive something for production of production of some kind of stuff to prevent damages and all. Now, for us changing this guy from caustic alkaline to reduce the reactivity, and we don't want to use a deliquescent substance, what do we have to do? We now have to make soda lime. Now, what is soda lime? Soda lime is the mixture of caustic alkaline, which is sodium hydroxide, and slaked lime. What is slaked lime? We mean calcium hydroxide. This is what we mean by slaked lime. Okay, so now this we will now have to use soda lime instead of our caustic alkaline. So now you get, I just wanted you to note this point. These are points you should note. Instead of using the normal caustic alkaline, we are now using soda lime to perform the experiment. Now let's dive in straight into this preparation. Now, as I said, the reaction of salt of alkanoic acid and caustic alkaline will give us our corresponding alkanes. Now, but there is something you have to do. This reaction cannot go on except in the presence of heat. Okay? Now, which one will we use? We are going to use sodium ethanoate. Now, sodium ethanoate is written as this. As I said, it will react with sodium hydroxide. Remember, in the presence of what? Heat. There will be a presence of heat to give what our corresponding what? Alkane. Now, but the product that it will give us, it will not be only alkane, because there are other compounds here. So now it will give us what? Sodium carbonate. Okay, this is what it will give us, sodium carbonate, and finally our corresponding alkane. Now, this is one of the preparation of alkanes. All right, but now we have gotten our alkane. As a smart student, we know that our caustic alkaline here can actually remove CO2 from a reaction. So now wait. Now the word decarboxylation, it means something. It's not just given to it as a name. Decarboxylation is the removal of CO2, which is what? Carbon dioxide. And we know that this guy here, caustic alkaline, its work is a very popular question. You will know its work is removing CO2 from a reaction. So now we can now say, without using our alkanoic acid, the salt of our alkanoic acid, we can use only alkanoic acid to give us what? Our corresponding alkane. Now let's use what? Our ethanoic acid. Our ethanoic acid now is like this compound, but there is a difference. There was no hydrogen. There was hydrogen originally before it was displaced by this sodium. Now, which is now called what? Sodium ethanoate. Okay, don't forget this compound is called sodium ethanoate, but the original compound was originally ethanoic acid. So now ethanoic acid is written as this. Sorry. Okay, ethanoic acid is written as this. Now if under the influence of what, our caustic alkaline, which is sodium hydroxide, CO2 will be removed from the reaction to give us what, our corresponding alkane, and what, it will displace what, our CO2. So now the preparation of alkanes is as simple as this. Remember, this guy is what, ethanoic acid. But when it is displaced by a sodium ion, it will become sodium ethanoate. Okay, just note that. Alright. These two reactions are technically almost the same. But as a wise student, if you know this one, you know this one. And if you know this one, you know this one. Okay? So now let's dive in further into more about alkanes. Here, the physical properties of alkanes. There are things you have to know. We know that the first member of the alkane family is methane. And from methane going down, the molecular formula is increasing. But that's not what we are here to do. There are things we have to note about them, which are their physical properties. The first four carbon are what? They are gaseous. Note it. So carbon 1, which is methane, including methane, to carbon 4. What do we mean? We mean methane, ethane, propane, and butane are what? Gaseous. They are what? Gaseous. They are in gaseous state. Okay? Now, the next 13, which is carbon 5 to what? Carbon 17, are liquid form. They are in liquid form, which means they are in liquid state. Okay? Now, finally, carbon 18 and above. So from carbon 18 going down, as the molecular formula is increasing, they become what? They don't just become solid, because most people will say they exist in solid state. No, they exist in waxy solid state. Alright? Waxy solid state. Now, the final property you should note about them is that note, which is all alkanes. Note it, all alkanes are soluble in what? In non-polar solvents. What do we mean by non-polar solvent? E.g., an example is what? Benzene. Okay. Now, but you should also know that alkanes are not soluble. They can't dissolve in polar solvent. Example of polar solvent is water. Alright? So now, these are the things you should note about alkane. Now, if we mean what do we mean by soluble? As I said earlier, it means it can dissolve, which means what we're trying to say here is that alkanes dissolve in benzene, which are non-polar solvents. Alright? Now, moving forward. Yes. Now, finally, reactions of alkanes. Now, the first reaction of alkane is called what? Halogenation of what? Alkanes. Now, halogenations of alkane. What do we mean by halogen? It's very simple. It has to do with halogens. Well, now, what do we mean by halogens? We simply mean fluorine, chlorine, bromine, and iodine. But now, in the reaction of alkanes and halogens, iodine is not included, because iodine is not as reactive as the rest. It can't react with alkane. That is why we have a word we call chlorination, bromination, but we don't have iodination. Okay, so now let's move on. Okay, the general formula goes like this. We have the general formula today. This is the alkanes. We react with halogens to give what? Note. This is a photosensitive reaction. So there must be a presence of what? Ultraviolet light, UV light. Okay? So to give us what? ROX plus what? Now, this is how our reaction will be. So now, following from the look of things, this is our general formula for halogenations of alkanes. Now, let's pick any examples of alkanes to experiment on this reaction. So now, let's go. Let's pick the simplest one, which is called what? Methane. Now, which one will use chlorine as an example? But wait, this reaction we're about to do now is a step-by-step reaction. It's not a simple reaction we can just do once and get rid of. No, it is a continuous reaction. Okay, so now what will happen here? If we react with both of them, we will get what? CH3. This chlorine here displace one hydrogen. Alright, so it will now be this plus what? HCl. It will form HCl. But wait, from the look of things, what will we call this? We'll call it what? Chloromethane. Or methyl chloride. Okay guys, now we've gotten the first compound which the halogenation of alkane will give to us, chloromethane and what? Methyl chloride. Now it will further react with what? Methyl chloride to give us what and what. Now we have to clean this out. Remember, there is always a presence of UV light in this reaction. Ultraviolet light, there is always a presence. So now we have to clean this out and further react chloromethane. Okay, now the further reaction of chloromethane is this, as we might have it. Now if we further react this with a chlorine molecule under the influence of UV light, what will it give to us? To give us CH2 to be displaced under hydrogen again and give us what? 2 chlorines. Now we will now finally have our HCl. But wait, there's something I want you to note. This HCl here, is it hydrogen chloride or hydrochloric acid? Now note it now. HCl can exist in two states. If it's in liquid, it is hydrochloric acid. If it's in gaseous, it is hydrogen chloride. But from the look of things, the original reaction was what? With methane. Methane is what? Methane is a gas. Chlorine is what? Chlorine is a gas too. So the combination of those two gas will definitely not give us water. It will give us what? Gaseous state of what? HCl. So what is there now is hydrogen chloride, not hydrochloric acid. Okay, so now moving forward, from the look of things, we've gotten our reaction. But what will now call this guy? We'll call him dichloro what? Methane. Or what? We can also call this guy what? Methylene. Methylene what? Chloride. We can also call it methylene chloride. Now, if you've been following before, I mentioned that the difference in the homologous series is what? Methylene group. The methylene group is what? CH2. So now, from this CH2, that's where they got this name methylene and chloride. Then the second name is di, because 2 chlorine dichloro what? Methane. Okay, so it's as simple as that. It's just logical. So now let me clean this up. Let's write the further reaction of what? Dichloromethane. The further reaction goes like this: CH2 C2, that is dichloromethane. We further react to what? Chlorine molecule under what? The influence of UV light to give us what? Now what we have here? Okay, now the chlorine now will displace another hydrogen, leaving us with what? CH alone with what? How many chlorine? 3 chlorine. To give us what? Our HCl, which is what? Hydrogen chloride. Okay, now what do we now call this compound here? Now, simple. We call it what? Trichloro. Because of the three chlorine here. Trichloro what? Trichloromethane. Or chloroform. Now, finally, since we've gotten the names, it doesn't end here. There is a further reaction. Alright guys, now let's do the final reaction. CHCl3 will now further react with our chlorine molecule to under the influence of our UV light to give us what? Now it will displace the final hydrogen, and now there will be no hydrogen left in this reaction. Okay? And finally our HCl. So now, from the look of things, what do we now call this compound here? So now, we'll call this compound what? Sorry, something is missing here. Remember, it's 4. Yes. There will now be 4 chlorine here. So now, what do we now call this guy? Because if you make mistake, you will get the name wrongly. So we'll call this guy tetra, because it's 4 chlorine. Tetra what? Tetrachloromethane. Okay. Now, the final guy will be what? It will be called what? Carbon tetrachloride. Okay guys, this is all you have to know about the halogenations of alkanes. Okay guys, now I just want you to know this very quickly. Now, from the reactions, you notice we had the first product. That one doesn't really have much use like that, but I highlighted the 3 most important so that you notice what. This guy, the second reaction produces dichloromethane, which is used for what? Refrigerant. Now the third reaction will give us what? Chloroform, which is used as an anesthetic product, which is used in what? Surgical operations. Now if we use this chloroform in the anesthetic, it will make the patient not to be able to feel pain, for us to be able to like commence the surgical operation. Okay, then finally our tetrachloromethane. This one is a very important organic solvent. That you just have to know that about that. Okay, now there's something else I want to add. I said it earlier, but I want to note it well. Now our fluorine is more reactive to alkanes than what? Our chlorine. After chlorine we have what? Bromine. And before what? Iodine. Now iodine is the bad egg. It's not reactive. If you remember, I said it that iodine does not react. It does not iodination. Like the way we have chlorination, bromination, we don't have iodination. Okay, it does not react. So we only have chlorination, and bromination. Alright? That you should note. But note it, fluorine is the most reactive towards alkane than chlorine before we now have bromine. Okay? Finally, the combustion of alkanes, the second reaction that takes place in alkane. Now, there is this thing I want you to note. Combustion is all about the burning of organic compound in the presence of air or oxygen. Alright? So now, if this thing takes place, there is always 2 products that you must have. You must have what? Carbon dioxide, which is CO2, and water. Alright? So now, let's write the general formula, the equation we use in getting this thing accurately and fast. Okay guys, now let's write the formula. It goes like this. We know alkane is the one undergoing the combustion. So now let's write the formula of alkane. CnH2n plus 2. Okay, it will now react with what? Oxygen. Now, but we don't know the number of moles of oxygen, so we just have to first put what? O2 here. There are some things we have to put here. But first, the reaction will not give us what? It will give us, first of all, CO2, which is our carbon dioxide. Now, we don't know the number of CO2 it will produce, so we just put N there, okay? Then finally, we get our water molecule. But our water molecule, we don't still know the number of water molecule. So we write it like this. This IT is written H2. Okay, now we have to figure out how to put this guy here. Alright? It is now written like this. 3m plus 1 over 2. Okay? Now guys, this is the formula or the equation we use in getting our combustion formula accurate and correct. We've gotten the formula. So now what do? We have to take one as an example to cross check if this formula is actually correct. Now remember about combustion, there is always what? The product is always what? CO2 and what? Water. CO2 and water. Okay? Note that. If this combustion takes place in limited supply of oxygen, what will happen? We will not get CO2 again, we will get CO, which is carbon monoxide. But let's leave that. Let's move over to testing our equation. Okay, now if we want to test our equation, it's very, very simple. What do we do? Let's pick the first member of the alkane family, which is methane. Now, methane is denoted with the number N equals to what? 1. If N is equals to 1, we write it like this. We now have methane. If you calculate N times 1 times this plus this is 4. Okay? So now, let's move on. Now, in this bracket, we know N is 1. So, 1 times 3 will give us 3 plus what? 1. Which is 4. 4 over 2. It will give us what? 4 over 2 will give us 2. Okay? So now, let's just clean this out and write our what? 2. So we now have 2 molecules of oxygen molecule. 2 moles of oxygen molecule, right? Now, it will now give us what? We know that the number N is representing 1. So we don't have to write it CO2. Okay? Then what? Finally, our N, that is 1, representing 1. 1 plus 1 is 2. 2 moles of water molecule. Now, if we now cross-check this thing, we observe where that our oxygen, our carbon, and hydrogen is balanced on both sides. So this equation is balanced. This is the combustion of what? Methane. Alright? So now let's move on to finally the last reaction of methane, which is what? Pyrolysis. I will tell you what pyrolysis is. Yes. Now, what do we mean by pyrolysis of alkane? It is very, very simple and easy. Now, pyrolysis of alkane also means what? Cracking. Note it. It also means what? Cracking. Anytime you hear pyrolysis, we mean cracking. Alright guys, so now guys, what do we mean by cracking? It is the breakdown of larger molecules of alkane to give what? Smaller alkane and alkene. It will not only give us alkane after the breakdown, it will give us alkane and what? Alkene. So now let's take an example to cross check it. Let's use what? Butane. Now we write this as what? How many carbon in butane is 4. Alright guys, this is what? This is butane. So now, also note this, during cracking, we need what? It takes place in what? Presence of what? Heat, high temperature. Alright? So now, under this high temperature, it will break down to what? A corresponding alkene. Now, which alkene will it now give to us? It will give us what? And what? It will give us this alkene and this what? Alkene. So now let's count. This will give us 1, 2, which is what? Ethane. This is what? Ethane. So when we break down butane, we get ethane and what? Ethane. Alright? Now, this is what I mean by cracking. It will break down a larger molecule of an alkane to give us a smaller molecule of alkane. Alright? So now that is all you need to know about pyrolysis of alkane. Now, what else do we have to note? Finally, we have to know that the uses of alkane is very simple and very precise. We note that alkane is used in the production of fuel, and is also like the first member of alkane, which is methane, is also used as a fuel. So aside that, it's also used in the production of organic compounds which are used for anesthetics and used as refrigerants, and finally as organic solvent, like those chloromethane, dichloromethane, tetrachloromethane and trichloromethane that we listed before. So alright, that are the uses of alkanes. Now finally, let's look into the first member of the alkane family, which is methane. Okay guys, now finally we have to talk about methane. Now it's very simple. I'll give you points you should note about methane. Methane has the general formula of CH4. Now methane can be found in what? Petroleum gases. Alright? Now we also note that methane is a major constituent in what? Natural gas. Okay, aside this now, what else should we note? Methane is given off in swamps, which is why it was given a name called marsh gas. So anytime you hear marsh gas, we are talking about what? We are talking about methane. Alright? Now, next up, what do we note? We have to know that methane is found in polyventilated coal mines. Polyventilated coal mines. We can find methane in polyventilated coal mines. Alright? We can find methane in polyventilated coal mines. Okay, next up that you have to know. Because it is found in polyventilated coal mines, due to any spark or any ignition, it causes explosion in coal mine. So now, this is a very popular question, okay? That's why I'm emphasizing on it. Anytime you hear that there is a question that says which organic compound causes explosion in coal mines, we are talking about methane, okay? Note it, we are talking about methane. Explosion in coal mines, we are talking about methane. So as I said, it's also called marsh gas. A major constituent in natural gas is a constituent of petroleum gas, and this is the general formula. Alright? So now finally, the final thing we have to note about methane. Methane is produced from the decomposition of plant matter in the absence of what? In the absence of air. Note it, in the absence of air. So it doesn't occur when there is presence of air. So when this plant matter decompose without air, it will give us what? Methane. And finally, where we can also find it, as I said, we can find it in swamps. It's given off in swamps. Okay, that is all we need to know about this compound called methane. Alright, and remember, the structure of methane, as we drew before, is this. This is the structure of methane. Alright guys, thank you guys for watching.
My king, I dey tell you, that boy no fit keep your secret. Me wey don dey knack your wife for 2 years, you know.